A nebula is a cloud of hydrogen gas and dust in space. Nebulas are the birthplaces of stars. There are different types of nebulas. An emission nebula, e.g., such as Orion Nebula, glows brightly because the gas in it is energized by the stars that have formed within it. In the pictures playing, you can see an Orion Nebula. In a reflection nebula, starlight reflects on the grains of dust in the nebula. The nebula surrounding the Pleiades cluster is a typical reflection nebula. In these pictures, you can see reflection nebulas in all different colors. Dark nebula also exists. These are dense clouds of molecular hydrogen which partially or completely absorb the light from stars behind them. The Horsehead Nebula is in the Orion. Planetary nebula are the outer layers of a star that are lost when the star changes from a red giant to a white dwarf. The pictures playing are black nebulas. A star is a luminous globe of gas producing its own heat and light by nuclear reactions, called nuclear fusion. They are born from the nebula and consist mostly of hydrogen and helium gas. Surface temperatures range from 2,000 degrees Celsius to above 30,000 degrees Celsius, and the corresponding colors from red to blue-white. The brightest stars have masses 100 times that of the Sun and emit as much light as millions of suns. They live for less than 1 million years before exploding as a supernova. The faintest stars are the Red Dwarfs, less than 1,000th the brightness of a sun. The smallest mass possible of a star is about 8% that of the Sun, 80 times the mass of planet Jupiter. Otherwise, nuclear reactions do not take place. Objects with less critical mass shine only dimly and are termed brown dwarfs on a large planet. Towards the end of its life, stars like the Sun swell up into a red giant before losing its outer layers as a planetary nebula and finally shrinking to become a red dwarf. Red giants. This is a large bright star with a cool surface. It is formed during the later stages of the evolution of a star like the Sun. As it runs out of hydrogen fuel at its center, red giants have diameters between 10 and 100 times that of the Sun. They are very bright because they are also large. Although their surface temperature is lower than the Sun, they are still very large stars, and are often called supergiants. These stars have diameters of up to 100 times that of the Sun, and have luminosities of 1 million times greater than the Sun. In the pictures playing are beautiful red giants. The red dwarf is the next stage in the star's life. They are very cool, faint, and small stars, approximately 1/10 the mass and diameter of the Sun. They burn very slowly and have estimated lifetimes of 100 billion years. This is a very small hot star called the white dwarf, the last stage in the life cycle of a star like the Sun. White dwarfs have a mass similar to that of the Sun, but only 1% of the Sun's diameter, approximately the diameter of the Earth. The surface temperature of white dwarf is 8,000 degrees Celsius or more, but being smaller than the Sun, their overall luminosity is 1% of the Sun or less. The supernova is the explosive death of a star, and are often results of the star obtaining the brightness of 1 million suns for a short time. There are two general types of supernova. Type 1. These occur in binary star systems in which gas from one star falls onto a white dwarf, causing it to explode. Type 2. These occur in stars 10 times or more as massive as the Sun, which suffer runaway internal nuclear reactions at the end of their lives, leading to an explosion. They leave behind neutron stars and black holes. Supernovae are thought to be main source of elements heavier than hydrogen and helium. Neutron stars. These stars are composed mainly of neutrons and are produced when a supernova explodes, forcing the proton and electrons to combine to produce a neutron star. Neutron stars are very dense, typical stars having a mass of 3 times the Sun, but diameter of only 20 kilometers. If its mass is greater, its gravity will also be strong, that it will be shrunken further to become a black hole. Pulsars are believed to be the neutron stars are spinning very rapidly. Black holes are believed to form from massive stars at the end of their lifetimes. The gravitational pull in a black hole is so great that nothing can escape from it, not even light. The density of matter in a black hole cannot be measured. Black holes distort the space around them and can even suck neighboring matter into them, including stars. The pictures playing are black holes. That's the end of the slideshow. Thanks for watching!